I just love cheese, but what's the chemistry behind how it's made? And what are some of the key flavour molecules of some stinky and slightly less stinky cheeses? Cheese is basically a byproduct of adding acid to milk. Milk is made up of 86% water and solids, which are mainly proteins called casein and whey. To make cheese, you have to separate these two proteins. If the milk is unpasteurised, which means it hasn't been heat treated to remove most of the bacteria naturally present in the milk will start to turn it sour. If the milk has been pasteurised, certain types of bacteria have to be added which help convert lactose, which is the sugar found in milk, into lactic acid, reducing the pH. To make the structure of the cheese stronger and for the curdling to happen quicker, cheesemakers add the enzyme rennet, which helps casein cluster together. Usually in the milk, the casein floats around as micelles, little self-organised spheres with a negative charge on the outside which therefore repel each other. But to make cheese, you need to get the casein to join together. Lowering the pH by producing lactic acid, a source of H+ ions, neutralises this charge. This means the proteins can start to clump together and form curds, a soft, rubbery gel. The mixture is broken up and the curds and the watery whey are separated. In cottage cheese, much of the whey is drained, just leaving the curds. A firmer cheese has less whey in it and usually has a longer shelf life, whilst ones that are more rubbery contain more whey. The longer you leave a cheese to mature, the more lactose is converted into lactic acid. Older cheeses therefore tend to have a sharper taste. Blue cheeses have bacterial cultures added, either when the curds separate or when the cheese has been pressed and bacteria injected, forming veins of mould. The most important odour molecules of blue cheeses are a class of compounds known as methyl ketones, and two in particular, heptantuone and nonantuone. The smell of the ketone depends on the size of the molecule, but the most abundant ketones in blue cheeses have 5, 7 or 9 carbon atoms. In gorgonzola, nonantuone is most abundant, but there are other molecules present. Taste a piece of gorgonzola and see if you can detect a mushroom flavour from 1-octanthreol or ethylhexanoate, which gives a fruity pineapple taste. In cheddar, you'll find over 100 different odorants, with furanol and homofuranol imparting a buttery taste, methional as a taste most commonly found in boiled potatoes, and ethanoic acid, which is found in vinegar, as a sharp taste. Try some cheddar and see if you can taste these different molecules. All cheeses essentially start life the same way, but the vastly different aromas, textures and tastes are created by a complex set of reactions which we owe to chemistry. For more edible experiments and the chemistry behind certain foods, check out my other videos and demo sheets.